So sigma notation is essentially just another way to show series. Okay, so sigma notation is this Greek letter here. It looks like an E, but this is called sigma, and it's actually a Greek letter S, and it stands for sum. So anytime you see this sigma notation, we're going to be looking to add up a whole bunch of terms. So how does this sigma notation works? Okay, so since we're adding up all the terms, we're basically describing a series. And the way the sigma notation works is that this term in here represents the Tn. Okay, so this is how we're going to generate each individual term of that series. Now, this happens to be a geometric series, and our examples are geometric series, but this sigma notation can express any series. Okay, it could be arithmetic or some other series that generates a Tn formula that we don't know, could be arithmetic or geometric or some other thing. Okay, so sigma notation works for all series. So the way sigma notation works is that we have our Tn formula. So this is going to generate all the terms. The number down here tells us which term we're going to start at. Okay, so we could start at 1, we could start at 0, we could start at 18, doesn't really matter. And then this tells us where we're going to end, the term number that we're going to end at. So essentially it tells us how many terms we're going to add up. So how does this work? Okay, so looking at this example here, this is our Tn formula. Okay, it happens to be a geometric sequence. And we're going to start when n equals 2. So notice that we don't have to start at 1. And we're going to go to n equals 6. So there's going to be 5 terms that we're going to add up. So how do we do this? Well, we're going to just find each of the individual terms by using the expansion. So we're going to just let n equals 2, and we're just going to plug it in. So we get 2, 3 to the power 2 minus 1. That's the first term. Then we're going to go plus, because we're going to add up all the terms in this sequence. The next term is going to be 2, 3 to the power 3 minus 1, plus 2 to the power 2 times 3 to the power 4 minus 1, plus 2 times 3 to the power 5 minus 1. Okay, and we're at n equals 5. We need to get to n equals 6 to get the last term, so plus 2 times 3 to the power 6 minus 1. So what we've then done is we've just generated the individual terms using this in Tn formula, and we just add this all up. So here we get 2 times 3 plus 2 times 9 plus 2 times 27 plus 2 times 81 plus 2 times 243. Okay, so, and then we, use our calculator, we can add those all up. But again, the idea is the sigma notation is just another way to write series. This expression gives us the terms of the series, each individual term, and it could be geometric, could be arithmetic, it could be some other type of sequence. The bottom number tells us what n to start with. The top number tells us what n to end with. So looking at this next one here, we have an infinite series. This one happens to be geometric. Okay, so we probably want to know what the starting value is. The starting value is going to be 4 over 3. And for geometric series, we want to know the r. It looks like the r is 3 over 4. So we need to write this in sigma notation. So sigma notation involves the Tn formula. Well, for this particular sequence, the Tn formula, we need the a value. And we also need the r value. And it's going to be to the n minus 1. To get the first term, we need to let n equal 1. Okay, so we could actually take this away and let n equal 0, and we can start it. We can just start it. We can do this and let n equal 0. That would also work. Okay, but we're not as familiar with that, so we're just going to keep it the same as what we've seen before and just let n equal 1. And then we're going to let n go to infinity. Now there's a bit of a problem here in that I have to write the entire expansion out to infinity, which is impossible. But we've got some help here because we know that this actually is equal to the formula a over 1 minus r. So without that help, I couldn't do this problem because I can't actually write out every single term of this series. So the a value is 4 over 3 over 1 minus 3 over 4. We get 4/3 divided by 1/4. We get 16 over 3 as that infinite sum. So this one here, again, if you take a look at the formula, this is a Tn formula. You may recognize that this is this is a geometric series. So we want to solve for n in this geometric series. So we want to know how many terms there are. Well, we can kind of start listing them out and guess at this. That would be kind of hard, but we could do that and just kind of guess and test this. But we do have some help here again, because we do have, since this is an geometric series, we have a formula for the geometric series. Okay, as long as I know what a is and r is, so let's identify that first. A is going to be 32. R looks like it's 1/2. Okay, I have a formula that lets me calculate this. It's going to be a r to the n minus 1 over r minus 1. So I get this equation, 63.5 is equal to 32 times 1/2 to the power n. And we're going to make that big N because that's what we're solving for, minus 1. Just make that a little bit more clear. That's big N over 1/2 minus 1. Okay, so we get 63.5 is equal to 32 1/2 to the power n minus 1, and this becomes negative 1/2. Okay, so I'm going to just rearrange this a little bit. So 63.5 equals negative 64 times 1/2 to the power n. So I'm basically going to have to get this exponent and use logs to solve for this. Okay, so I'm going to divide by negative 64, so I'm going to end up with 63.5 divided by 64, negative 64. And so my equation now looks like this, 1/2 to the power n minus 1. This ends up being, if I simplify this fraction, this ends up being 127 over 128, and that's negative. I'm going to plus 1 on both sides. Okay, and then I'm going to set up my log. So this becomes 1 over 128 equals 1/2 to the power n. So n is equal to log base 1/2 of 1 over 128. Okay, now you can put this in your calculator if you like. Okay, but 2 to the power 7 is going to be 128, so n equals 7.